Welcome, and this is Sarman, Assistant Professor, Department of AI&DS. Today I am going to handle the subject design analysis of algorithm. Topic is Quicksort using divide and conquer method. So, what is Quicksort? So, Quicksort is a sorting algorithm that uses the divide and conquer strategy. The process of Quicksort involves three main steps. First, it will divide. Divide nothing but we are going to split the array into subarrays that each element in the left subarray should be less than or equal to the middle of the element, and each element in the right subarray is greater than the middle of the element. The splitting of the array into two subarrays is based on the pivot element. We are going to choose the pivot element in the Quicksorts. All the elements that are less than the pivot element should be left subarray. All the elements that are less than pivot elements should be in the left subarray, and all the elements that are more than pivot elements should be in the right subarray. Second concept is the two subarrays are sorted recursively by using the conquer. Finally, we are going to combine all the sorted elements in a group to form a list of sorted elements. In the method, the division of array is based on the position of array elements, but in the Quicksort, this division is based on the actual value of the element. So this is the diagram. This is known as the pivot element. The left subarray, the elements that are less than the pivot element. The right subarray should be elements that are greater than the pivot element. Consider the example. Let us consider the example with the help of some. Step 1. These are the elements, the 50, 30, 10, 90, 80, 20, 40 and G. First is set as the pivot element I value, and the last element set as the J value. Now we split the array into two parts. The left sublist will contain the elements that be less than the pivot element, and the right subelement contains the greater than the pivot element. So by using the algorithm, we are just increment the value of I. Next, we are using the if A of I is less than equal to. So first I explain the algorithm, then I move to the. So these are the problem statements. This algorithm performs the sorting of elements in array. The problem descriptions. Input given the array, output is create a subarray which is sorted element in the ascending order. If A of I is less than equal to low, if A of I is less than, split the array into two subarrays. Then M is nothing but we are going to find the middle of the array. Then quick, we are going to subdivide the low and mid plus 1, partition two values is Quicksort. So problem descriptions, partitions the subarray using the first element as the pivot element. Input subarray, output should be a partitioning. So pivot element is equal to, this is the algorithm, main algorithm. The pivot element is equal to A of low. We are going to set the value I equal to low, J is equal to I plus 1. While I is less than equal to J means we are going to, while loop, if condition is 2 means we go to the loop. While A of I is less than, we are going to increment the value of I. If A of I is less than equal to pivot elements, we are going to increment the value of I. If A of I is greater than pivot elements, we are going to decrement the value of I. If A of I is less than equal to means, then we are going to swap the value. When A of I is crosses J means we are going to swap A of low comma A of J. So there are four conditions. First condition, while A of I is less than equal to pivot element means we are going to increment the value of I. Okay. While A of J is greater than pivot element, we are going to decrement the value of J. While if I is greater or less than equal to J means we are going to swap the A of I and the A of J. Then finally, when A of low, when I is crosses J means we are going to swap the A of low and A of J. Now we move to the consider the example. So first element is for 50, 30, 10. First condition is you have to check the first condition I is less than equal to J. I is less than equal to J means we have to compare the A of I is less than equal to pivot element. A of I is less than equal to pivot element, we are going to increment the value of I. So the same condition is true, we are going to increment the I. If A of I is greater than equal to A of low means we are going to stop the incrementing the value of I. Here the A of J is greater than pivot element, so 70 is greater than 50 means we are going to decrement the value of J. A of I is less than equal to J pivot elements, we are going to decrement the value of J. We will continue the decrement J until the element pointed by the J. So A of j is greater than pivot element. So 70 is greater than 50 means we will decrement the value of j. We will continue to decrement the value of j until the element is predicted by the less than A of low. The same process is repeated until the step 8 and the step 9, step 10. So this is the conditions. A of j is less than equal to A of j. J has crossed I means we will swap the A of low and A of j. Okay. So finally, this is the now the pivotal is shifted the position 50. Now we will get the left sublist. The right side we have the right sublist. Okay, we will start sorting the left sublist. Now we have to choose these elements. We have to choose these elements and set as the pivot element here, the left side. Again the process continued. Here the first element set as the pivot element. The same process repeated until the left sublist and the right sublist here. Until the process is repeated until the up to step 20. Then finally we can get these sorted elements in the Quicksort. So analysis, if the array is always partitioned at the middle, so that running time of algorithm is equal to T of n is equal to T of n by 2 plus time required for sort left sublist and time required for sort the right sublist plus n is nothing but time to compare the partition in the subarray. So T of n is equal to 2t n by 2. This is the time complexity analysis. So finally the best case of Quicksort is T of n is equal to big O of n log n. The worst case analysis is nothing but pivot is the worst case is nothing but the search element or the sorting elements should be smallest or largest elements. Time required for the worst case analysis. The worst case of the Quicksort occurs when the pivot is a minimum or maximum of all the elements in the list. It's graphically represented as the time required for the n elements, then time required for n minus 1 elements up to we can 1 elements. So we can write as the time complexity of worst case analysis T of n is equal to n into n plus 1 by 2. So time complexity of worst case analysis is equal to T of n is equal to big O of n square. Thank you.